So you still have some people that are not doing the best in terms of lines.
Yeah, and the one cast member that was doing the worst out of everyone is convinced.
Isn't it hard to say that you have your lines down if you keep messing up?
Oh, not just messing up, but breaking character.
Oh, ad-libbing. I like that personally. I kind of like ad-libbing. Yes. Good news. So I have figured out, Mr. Lifner helped me figure out how to use this to record. So I will try to record, which I'm doing right now actually. I am. So I will try to just do that, and I'll try to post them online for you.
Do you have Arizona?
Yeah, I do. Is it just Wednesday you're gone?
Yeah, but then like 2 weeks from now I'll be gone 3 days.
Right, so I'll do the same thing. I'll try to record it, which hopefully will help keep you up a little bit better than just taking notes. Okay. For those people, yeah, I have found a way to record this using my Mr. Lifner helped me set this up on our in-service day. So if you know you're going to be absent, please let me know, and I will try to record it. We are really now kind of starting to switch gears. I don't like teaching to a Chem Regents test. Like, I try not to spend like all of our time just focused on a test. As we move closer to it, however, I start to obviously build much more to try to get us ready for the Regents. All right, so I don't like to what they call just teach to the Regents test, but as we get closer to it, I want to obviously get us prepared. So we're starting to make that transition. It's amazing how fast this time of year goes. If you think about it, we've got, spring break that's coming up, and then after spring break, with the amount of field trips that happen, it just time flies. So you guys are on your way to your senior year, and some of you are on your way to out of here. So that's awesome. Okay, quick look at the board. Homework tonight is going to be memorizing your definitions on acids and bases. If you're like Rowan and you did it last chapter, you may be ahead of the game. Because remember, I made that mistake and some of you did the wrong memorization. So maybe you can, Rowan, you can thank me. All right. Thank you for making me feel like we have hope in this world for the next generation. All right. We are starting here, acids and bases, and what you'll notice here is I have a page of goldenrod paper. Now, if you're interested in things like forensics or things like that, you probably have seen secret messages. So I'm going to make you a secret message, and obviously you agree with me.
What does it even say? I can see. He's in the way.
I gotta get this off here so you can actually see it go away.
He's in the way.
Well, at least I'll move it. There. So, chem is great. How in the heck did I do that? Besides being a magician.
Oh, that's a pretty color actually on the paper.
Yeah, is it like a white crayon? Like you do on Easter eggs?
Excellent idea, and it's very close, but it is not a crayon. But you're thinking about this right. Not chalk. Not marker. It's very similar to a crayon, but it
Is
is.
it like a pastel or like a...
What?
Well, let me. Oh, good thinking, Hannah. So I, first of all, have here a special type of paper, which is essentially called indicator paper. Anyone know what it is? Excellent. It is a paper, or sometimes it's just a strip, that changes color in an acid and in a base. This is called goldenrod yellow. And it is yellow when you're in an acidic environment, and it is red when you are in a basic environment. So what I did is I used my knowledge of polarity to make this work. And let me give you an analogy here. Chem is Great was written in by a candle. All right. Now, if you were looking really closely, you might have been able to actually, it's not completely clear when you put a candle on there. You could kind of maybe make out the outline, but it'd be pretty tough to read. Then what I did is I took a solution of sodium hydroxide, which is a what? a base. I soaked it in just on a piece of paper towel. It's a pretty dilute solution, 0.1 molar, but it's basic. And I took that and I just started to rub it all over the paper. Now, paper is full of ions. Ions mix really well with polar substances, and water, which is what the sodium hydroxide is dissolved in, is very polar. So most of this paper picks up that red, picks up the water with the sodium hydroxide really easily, and it turns brilliant red. Why does the wax not allow the color change to occur? Wax is nonpolar. The water that has the sodium hydroxide is polar and likes dissolve likes, which means if you're unlike, you're not going to mix. And so what happens here is that I essentially protect my waxed area from encountering any of the base. And so it's kind of an acid-base reaction. It is, and it's also dealing with polarity and non-polarity, which is kind of cool. Now, I usually do this demonstration with ammonium hydroxide, and remind me tomorrow to do it with that, because ammonium hydroxide is really cool because it is a base that turns into a gas. It actually is a gas at room temperature, so it doesn't stay this way. It starts to evaporate. What do you think happens when the base evaporates? Yeah, it completely goes back to yellow. So it's pretty cool. It's like you get a message. So it'd be like on a movie where you need someone to see something in a certain time frame, and then it just goes away. So pretty cool. This would be like the best. I should have proposed this way. And then it would have given my wife like a certain time to answer. She'd have to answer quick before it evaporated.
Just do it for like,
I should do that for Valentine's Day.
yeah.
I'm starting to get creative. What kind of what? Yeah, I know. Coming again.
Mother's Day. Write her a sweet note.
There you go, Mother's Day.
Ooh, I like that. I might do that. My kids would love doing that, actually.
You
Maybe
can always
I-
make it reappear. If you
Maybe I don't want someone else to read it.
Wink, wink.
So I'll just write her a secret letter. I had a chem professor who would say that acid-base chemistry is 95% of chemistry. Now what that means is we're going to start studying here acids and bases, and this is a huge part of chemistry because a lot of things take place in acidic or basic mediums. So the first thing we're going to do is take a look at basically what are these guys, what are acids, what are bases. To do so, you'll want to have your reference table out. I will zoom in right now if I can. Let me just see if I can do it. Yep.
I hate school. It's really
Oh, that was on video. Madison hates school if you didn't catch that. I'm not sure why, but
I
she does.
got a really bad grade on my chem test, and I didn't even think it was that hard.
I got a horrible grade on
Well,
that chem test. So I thought
That
it
chem
was
test
really
didn't have a
fun.
lot of points either, so take that into account. I almost hate chem tests that are shorter because of that reason. But
Oh God.
Okay, one of my castellarian questions I didn't even answer.
But it,
Like it
Messed you up?
skipped it.
That happens to me all the
if
time.
that happens, let me know, and I'll try to make. Yeah, if that happens, let me know. Okay. First thing I want you to draw your attention to is that you have Table K, Table L, and Table M on page 6 of your reference table that you're going to deal a lot with during this chapter. Now, earlier in the year, I actually had you memorize the names and formulas for common acids and common bases. You may have forgotten that you did that, but you actually memorized them. And the reason I did that is because if you didn't know HCl was an acid, you would probably name it hydrogen chloride, and it's a different naming system for acids. It's called hydrochloric acid. And so I wanted you to recognize when you saw an acid or base. But you have here a list of common acids, common bases. You'll notice that every single acid contains what element? Hydrogen. Very good. And every single base, and I'm going to make a little bit of an exception here. Let's look at NaOH, KOH, and CaOH2. NH3 actually does contain this, and I'll show you how in a minute. But those three contain, and what do we call the OH ion? Anyone remember it? OH negative is called hydroxide. Very good, hydroxide. So you will notice bases are containing hydroxide, acids are containing a proton, and that's going to help us basically with a definition to define acids and bases. All right, so according to this chemist named Arrhenius, who proposed what is called the Arrhenius theory, we can say that the following is true. An acid is defined as a substance that yields hydrogen ions in aqueous solution. Now, these are called hydrogen ions, or they're called protons. Okay, they mean the same thing. A hydrogen ion and a proton are both represented by H+. And substances that yield H+ ions in aqueous solution are called Arrhenius acids. Okay, so an Arrhenius acid, I'm actually going to stick his name in front of this because in a minute we're going to talk about what's called a Bronsted-Lowry acid. So an Arrhenius acid is a substance that produces or yields H+ ions in aqueous solution. And let's go ahead and define here an Arrhenius base. And an Arrhenius base is going to be defined as a substance that yields OH negative ions, which are called, very good, hydroxide ions, in aqueous solution. So all acids that are Arrhenius acids are going to produce an H+ ion. All bases are going to produce an OH negative ion. Okay, we said that in our reference table that acids are going to be listed where? Yep, acids are going to be listed in table K. And we said bases are listed in table L. Important to know where to find them for when you have a question like this. Dissociate the following acids and bases. Dissociate the following acids and bases. So let's start off really easy with remembering how to dissociate an ionic compound, or in this case, dissociating an acid. Now that brings us to a very interesting point that we need to kind of review. What is an electrolyte? Very good. Something that conducts electricity, and it conducts, yeah, Gatorade, very good. It conducts electricity because it contains what in it? Ions. Yep. So, as a quick review here, an electrolyte is a solution that contains ions. What is an ion? Charged particle, very good. So an ion is a charged particle. And because it contains ion, it will conduct electricity. Alright, so it's a solution that contains ions, which is a charged particle, and therefore it conducts electricity. And normally, we said that electrolytes are made up of what type of compound? Ionic. Alright, so ionic compounds, as we know from our colligative properties, dissociate into ions in aqueous solution. So if you have a salt, alright, such as KCl, we could dissociate this, if it's in the aqueous phase, into what two ions? K plus aqueous and Cl minus aqueous. Excellent. This would be considered an electrolyte because it has ions dissolved in solution. Normally, covalent compounds, according to our colligative property songs, haven't learned to what? Dissociate. So normally, covalent compounds don't dissociate. Okay? But there is a group of covalent compounds that are renegades. They do not follow the rules. Does anyone want to take a guess on what they are? Nope. Good thought. We're talking kind of about them. Not bases, because bases are actually ionic. So they're kind of normal. But acids are the exception. Acids are the exception because you have something like hydrochloric acid. It is obviously covalent. Why do I say it's obviously covalent? There's no what type of atom? No metal. All right, none. No metal. So it's covalent, but yet it breaks apart. And how would it break apart? H plus. Perfect, Miss Thornton. H plus Cl negative, and this now, because it does produce ions, it is classified as an electrolyte, even though it is covalent. So let's look at a few acids on our table. We just did HCl. Let's take a look at HNO2, which is called nitrous acid. And let's go ahead and dissociate nitrous acid. Now here's the good news. Anytime you're dealing with an acid, you can automatically put what ion out there? H plus. So that's what you want to do. Always just start with the one that you know is going to be there, and in this case there's only one H, so you got H plus. Now remember, the NO2 is a what type of ion? It's made up of more than one atom. Not diatomic, that would be something like O2. Polyatomic. What chart on your reference table gives you polyatomics? Table what? Table E. What is the NO2 charge? Very good. So nitrous acid contains nitrite as the polyatomic ion. And as Hannah pointed out, the charge is NO2 negative. Almost all of your acids, other than HCl, are going to contain a polyatomic. So let's see if you can dissociate these two on your own. Try H2SO3 and try H2SO4. And I do want to bring attention to the fact that you're dealing here with an acid that has how many protons? 2. Madison, if you have 2 protons, that 2 needs to do what? Remember when we dissociate, what do you do with this subscript? Very good, Kaylee. It comes around to the front, so you're going to call this 2H+. Now, some people get carried away and they say, okay, then I need to put the 3 around to the front, but don't do that because the 3 is part of the polyatomic. Okay, if you think you can dissociate these, once I'll give you a chance here to just work on them for a second. Go ahead and try it. And then tell me what you get. Anyone want to take and venture out here and figure out what we have? 2H plus what? Very good. SO3 negative 2. Aqueous is the sulfite ion. Nicely done. That is how you dissociate the H2SO3 acid. Who wants to take sulfuric? H2SO4 is called sulfuric acid. H2SO3 is called sulfurous acid. Who wants sulfuric? There we go. 2H plus aqueous plus. Beautiful. And hopefully you again found the charges for both the sulfate ion and the sulfite ion on table E of your reference table, which is your polyatomics. Now there's a kind of a little exception here. When you get down to carbonic acid, you'll notice carbonic acid is listed as being written in 2 different ways. The first way is H2CO3 aqueous, and the second way is CO2 aqueous. And I want to talk about why this occurs. Anyone have any soda over the weekend? Soda? Pop? Rowan had some. All right. Now, a lot of people don't like pop or soda because it's too fizzy, carbonated. It stings your throat. Now, the reason it stings your throat is what part of soda does that? The what? The CO2. Yeah. It's the carbon dioxide that they basically bottle under high pressure that is making that stingy sensation. So if we were to look at carbonic acid, and by the way, this is what is in soda, all right, carbonic acid, it dissociates to give us 2H plus aqueous. Can anyone else figure out the other polyatomic? Very good. CO3, negative 2. What's it called? Carbonate. Very good. That is the carbonate ion. And carbonic acid forms 2 protons of the carbonate ion. Now here's why CO2 is listed also as carbonic acid. When you take CO2 aqueous and you dissolve it in water, you actually produce carbonic acid. And the carbonic acid can dissociate in this way, we'll call this way 1, to produce 2H plus and CO3 negative 2. Or it can simply go back to produce CO2 and water. All right? So I'll put a double arrow there on the first one to represent equilibrium. But to recognize that CO2 dissolved in water actually produces carbonic acid. And that is what you're feeling with that stingy sensation on your throat when you try to guzzle like a Sprite.
If you
Taylor.
forget like your aqueous or solid liquid or gas, will they mark off?
It depends on the question. Most likely, no. If they said, what is the phase or write the phases, then yes, but normally they wouldn't. You do want to, try to write them, though. It's important to try to keep them in there. Okay, this guy scares people. It's a very common acid that you consume, I would say, at least every other day, if not every day. What is it? CH3COOH. Ethanoic acid is one name. Acetic acid is another, and you know it as vinegar. It's vinegar. What's that?
I never.
Every day.
I bet you have it every day.
Vinegar.
What?
Okay, she doubts me. Name some things that have vinegar. Ketchup,
Pickles.
mayonnaise, pickles, salt and vinegar, chips. Almost any marinade you have will have vinegar. What's that?
Wait, if it's like a vinaigrette, is there vinegar in that?
Absolutely. Now we're thinking. Vinaigrettes. That should go on the board. So if you don't have one of those things during the course of a day, I bet you have it at least every other day. But I could be wrong. Maybe your diet is very vinegar out. But you also use vinegar in... is vinegar used to cook with much? Probably
Not
not.
really.
Yeah,
Used to,
not
like,
really.
clean with.
Yeah, it is used to clean, but it's probably not used
Help
to...
it cure yourself.
Oh, I know. I was going to say, you could guzzle it. Okay, now, Caleb's having a hard time with the vinaigrette comment. That was good. That was good.
Dumb. This is why I should be in chemistry.
No, that was funny. Okay, can someone dissociate this for me? And don't get freaked out. This is the proton right at the end that is given off. So just separate it from that big honking ion, which is called acetate, and go into table E and find acetate. It is. It's super easy. People get freaked out by this, but it's very easy. So pull your H plus off, your proton, and then you're going to get left over the acetate ion, CH3, CO negative. This is called acetate. By the way, remember that saturated solution I made that I said if you filled a swimming pool and jumped into it? We used sodium acetate, okay, to do that. So it's the same ion there present in both.
Is
And-
it cold? Would you like freeze or you just get stuck?
You just get stuck. Okay. Now, here's what's interesting. I want to compare these two. You've got acetic acid, which we consume almost daily in some form or another. Okay, good old vinegar. It's called acetic or ethanoic acid. And then you've got hydrochloric acid that if you consumed, you're likely going to die. And the question is, why? Why are some acids used all the time, whereas other acids are lethal? All right? What is the difference? Does anyone want to take a guess? Because it actually is not the ions. You consume Cl negative all the time when you eat what? Salt. And you obviously get H plus from vinegar, just like you do from hydrochloric. So it is not the type of ion here that is causing one to be lethal and one to be very consumable? Good thought. It is not, however. That is a very good thought, but it's not because the ions cancel out. It does have to do with the way it breaks down, but more importantly, how much of it breaks down. And here's what I mean. Good old acetic acid or vinegar undergoes what is called incomplete dissociation. And this makes it what is called a weak acid. HCl, on the other hand, undergoes complete dissociation, which makes it a strong acid. Now you might say, all right, well, what do you mean like incomplete? Well, here's what I mean. If you start off with 100 molecules of vinegar and allow it to dissociate, you're going to still end with like 99 as vinegar, and you'll get about 1% or 1 that actually breaks apart into ions. Almost all the vinegar stays with the proton connected. But on the other hand, when you have HCl break apart and you start with 100 HCl molecules, as you let it dissociate, you get 0 of these left and 100 of them turn into ions. That's why HCl is super strong, and that's why vinegar is very weak. One is very consumable. It doesn't burn your esophagus. I mean, it might cause some irritation if you like drink it, but I'm sure we maybe have all had, I don't know, a teaspoon of vinegar at some time in your life, maybe. But this guy is lethal. That guy is lethal.
So ions are lethal then?
Only if it's basically an overload of ions could be lethal. For example, a lethal injection kills you by pumping in too much potassium ion to your body. It affects your basically equilibrium of your ions, and that's how people are killed. Bases.
I was just 8 now. Oh my goodness.
We have just enough to get a dissociation for a base. Some common bases include things like NaOH. Please go ahead and dissociate NaOH for me. And you do this exactly like you would any other ionic compound. NaOH would be Na plus aqueous plus OH negative aqueous. Very well. Someone do KOH, which is called, by the way, these are named just like you would name any other ionic compound.
Oh, you shut off.
Thank you. This is sodium hydroxide.
Why is it doing that?
I'm videoing it, so it's actually running off the computer, not just the overhead. So it's when my computer falls asleep, you see it as a blank screen. And this is called potassium hydroxide. Who's got the dissociation of potassium? K plus OH negative, aqueous on both. Good job. Then we've got good old CaOH2 called calcium hydroxide. And calcium hydroxide, we've got an interesting little situation here where the 2 for the subscript is outside of the parentheses for hydroxide. Did someone dissociate it? Ca plus 2. Very good. It's a group 2 metal plus 2 OH negative. Anytime you have a subscript outside of the parentheses for a polyatomic, that is when you bring it around in front to get the 2 OH negative. And then we've got this weird guy, NH3 gas. Why do they classify this as a base? Well, it's kind of like carbon dioxide. When you take this and dissolve it in water, so NH3 gas plus H2O,
Why is it aqueous?
here's why. It starts off as a gas, and then as it dissolved in water, it becomes aqueous. But sometimes they will just write it as NH3 gas, telling you it's already been dissolved in water. Okay, good question. Because NH3 is a gas at room temperature.
Is that supposed to be solid?
No, this is a gas. Gas.
How do you dissolve gas?
You just bubble it into the water. You form NH4OH. Can someone name that for me? It's not ammonia, it's called ammonium. And then what? The OH negative would be called? Very good. Ammonium hydroxide. And then this dissociates. By the way, this has 2 polyatomics. What are they? NH4 plus and OH negative. So now this dissociates into ammonium and hydroxide ion, and that's why aqueous ammonia is considered basic. And that is Windex. Next time you wash some windows, think chemistry. Bases dissolve a little bit of glass, and so they clean glass very well if they're dilute. All right, so you got to memorize acids and bases for tomorrow. And that'll wrap it up.